We will start now. Fine. So in the previous class, we have started with our syllabus and we have studied the bisection method. And today we are going to study another method. This is called as Regula Falsi method. Okay. So this method is also called as method of false position. Okay. So it works on the similar line of this bisection method. Only thing is this is a kind of a improved version of the bisection method. Okay. So this is position. Okay. So let us start. So in the previous class we have seen that if you have a curve which is like this, say this is the curve. Okay. And if you are choosing 2 points like this, so this will be, let us say, p1 and this is p2. So here you see the value p or the point p2 is very far from the actual root. Okay, so this is a random guess. So this is a very common scenario where the assumed root is very far from the actual root. Okay, so now in the bisection method, what we have seen, the number of iterations which are required in this particular case, they will increase if you choose a route which is far away from the actual route. Okay, and for this purpose, what we are doing is we are using a simple expression xm equals to, that is x1 plus x2 divided by 2. So in short, this is your x1, this is your x2. So this exactly the center of that, this will be your xm. Now you see your xm is also far away from the actual root. Okay, so to avoid this particular scenario, this method is developed, and this method is called as method of false position. Okay, so in this method what is happening, let us see. So we have same curve. Okay, so I'm drawing the same curve one more time. So it is like this. Okay, so now in case if you are choosing 2 points, this is your p1 and this is, let us say, your p2. So now in this particular case, what exactly we are doing is we are drawing a straight line from point p1 to point p2. Okay, now when you draw a straight line between p1 and p2, this straight line is going to intersect somewhere over here, isn't it? Now this is nothing but your xm now. Okay, so not exactly the mean, but this is the possible root of the given equation. Now if you see both the figures, the figure which is there on the left hand side and figure which is there on the right hand side, you will find that the point which we have obtained by taking a straight line between p1 and p2 is much closer than the xm which we have obtained in the figure which is there on the left hand side. Okay, so for this purpose, what we are going to do is we are going to use a simple method of triangles. So here if I draw a straight line and here if I draw a straight line, so basically you have now two triangles. Okay, such as this coordinate is your x2. Okay, this is your x2, this coordinate will be your x1, this vertical coordinate will be your y2, here the vertical coordinates will be y1. Okay, so this angle will be same, this angle will be also same. So if you take the tan of theta, so tan of theta can be calculated by the opposite side divided by the adjacent side. Okay, and here also tan of theta can be calculated by opposite side, which is y1 divided by adjacent side. So with this we can develop a simple mathematical expression which can be used to calculate the value of xm. So this xm now can be calculated using that expression. So xm will be like this. Okay, so this is nothing but x1 y2 minus x2 y1, okay, divided by y2 minus y1. So this equation is developed using the similarity of the triangle. Okay, so all you have to do is just remember this. Now the entire process which we have seen earlier in the bisection method, the same process is applicable here also. Only thing is the expression of xm is now changed, and believe me, this is much faster as compared to the bisection method. So in this method we are going to get these results quickly as compared to the bisection method. Okay, so just to demonstrate this, we will go back in the bisection method. Now if you remember, in the bisection method we have taken an expression that is y equals to x cube minus 1.2 times x square plus 2x minus 2.4. So let us try to solve the same problem now using the regular Falsi method. Okay, so here you have y equals to x to the power 3, and I think we have minus 1.2 x square. So this is minus 1.2 x square. Then I think we have 2x and minus 2.4. Okay, so this will be plus 2x minus 2.4. Okay, so I will be not going into the graphics now. I'll directly write down a table for this. Okay, because the process is exactly similar, which we have seen in the bisection method. Okay, so let me insert a table. I need a table of 6 rows and 6 columns. This is sufficient for me. And let us say this will be x1, this will be your y1. Okay, this is say x2, this is y2, and this will be your xm, and this will be your ym. Okay, now the conditions are almost same for this method. So first thing is you have to find out the guess roots such that the corresponding y values lies on the either side of the x-axis. So one should be the positive value and one should be the negative value. Okay, and if you remember, in the previous class we have already found out this. So if you see this, the value of x is 1 and value of x is 2, such that the corresponding values of y, they are negative and positive. Okay, so let me write down the same thing over here. So I am taking the value of x as 1, the second value as 2, the y1 value we have calculated as minus 0.6. Okay, so this is minus 0.6, and the corresponding y2 value was 4.8. Okay, right? So now all we have to do is we have to use this expression over here. This is the expression for the uh, your xm, you can say. Okay, so here the same expression, this we have to use to calculate the value of xm. Okay, so now can anybody tell me what will be the value of xm with the help of the values which we have chosen? Somebody please do the calculations. Yes, students, please do the calculations. Give me the value of xm now. Sorry, 0 point. Can you please tell me the values in four up to 4 digit? Okay, that is 666. So I'm putting 7 over here. Okay, so if you refer the previous one, okay, हम लोग थोड़ा पीछे चलते हैं. So if you go back in the bisection method, what you will find that when we have chosen x as 1 and one root as 1, second root as 2, you have obtained the xm value was 1.5, exactly the mid of that. But when we are using this regular falsi method, you are getting a value of xm as 0.66667, and if you see, we have obtained the value of exact root as 1.2. Okay, so here you see we are quite closer to this one. Okay, so can you tell me what will be the value of ym for this? Yes, students, please. बताओ भाई, ym बताओ. minus 30 304 or 303.
Sir, by rounding off, it is coming 30.
Can you tell me in 4 digit, please? Don't use 3 digits.
303.
303 और आगे digit कौन सा है?
6031.
6 ले. ठीक है. Okay. So now you see, we have obtained the value of ym as negative. Are you sure it is coming out to be negative?
Yes, sir.
ये 0.6 से ज़्यादा नहीं जाना चाहिए बेटा. Please do the calculation one more time. Please do the calculation one more time.
Sir, for XM.
Sorry, XM ठीक से कैलकुलेट करो तो मुझे थोड़ा सा डाउट आ रहा है इस पे. This y1 and y2, are they correct? y1 and y2, 0.6 negative and 4.8. Please check the value of ym, sorry, xm, this one. Someone please check.
Sir, XM is 1.1111.
1 point.
1111.
Okay. ठीक है. That's why I was wondering, because ये लिमिट के बाहर नहीं जाना चाहिए actually. Okay, and what will be the corresponding value of ym?
Sir, minus 0.2875.
कितना आ रहा है?
Minus 0.2878.
2878. Is it so?
Yes, sir.
Someone please cross check.
Yes, sir, it is coming, sir. Yes, sir.
ठीक, good. So you see, if you refer the previous one, actual root था अपना 1.2, isn't it? And with just one iteration you will find that you are very very close to the actual solution in just one iteration. Okay, हम लोगों को 1.1 पहुंचने के लिए हमको कितने इटरेशन लगे थे? यहाँ पर देखो 1.1 हम यहाँ पर पहुंचे, that is at the iteration number 3. The value of xm was 1.125, and here in just one iteration we are reaching at the value of 1.1111. Okay, so you see this method is fast as compared to the bisection method. And why it is faster? Because we are assuming a straight line relationship between p1 and p2, and then we are getting the value of intersection. Okay, so now you see, here the value of ym is negative. Okay, so for the next iteration, what should I take value of x1 and x2? Can someone tell me? One should be positive and one should be negative. x1 क्या लेना चाहिए? 2. Okay, we can take 2. How about x2 then? Shall I take it 1 or 1.11?
1.1.
1.11. Okay, so what I'll do, I'll keep this at same. Okay, this value I am going to change, so this will be 1.1111. The corresponding value is negative 0.2878. Okay, and rest of the things are same. Okay, so now using this expression, that is xm equals to x1 y2 minus x2 y1 divided by y2 minus y1. Can you please tell me what will be the value of x1, please?
Sir, 1.1613.
1.1613.
Sir, 4 आना चाहिए लास्ट में, क्योंकि 3
Okay, someone please cross check this. Meanwhile, you do the calculation of ym.
Yes, sir, correct.
Okay, what will be the value of ym?
Sir, minus 0.129.
Okay,
Yes, sir.
okay, someone please cross check this.
Yes, sir. Yeah, yeah.
Okay, good. So you see, we are going now closer to the actual solution because the value of y is reaching towards 0. Okay, so again, you if you go for the third cycle, so this value is positive, okay, and this value is negative. Okay, so let me take the same values over here, 4.8. Okay, and this value I am going to change as 1.1614, and the corresponding y value will be minus 0.1293. Okay, so can you please tell me what will be the value of xm and ym?
One point one eight three.
Okay, and how about this one?
349.
34.
339. 34, sir.
34. Okay, fine. How about this one? Ym value
0.056.
56.
Minus.
Is it negative?
Yes, sir. Negative.
Okay, fine. So you see, in just three cycle, we have reached very close to the actual solution, which is 1.2. Okay, so you just focused on this value. This is 1.18, and if you go back here, so to reach 1.18, we required four cycles over here. Okay, and this is 1.1875. As far as this part is concerned, it is 1.1834. Okay, so all we have to do is just keep on going, and within the next cycle I'm sure you will get very closer solution. So I'm once again keeping this value as constant, so this is 1.1834, and this value as negative 0.0564. Just do the last iteration and give me the values.
1.19.
19. Okay, 28 or what?
Yes, sir.
Okay, and what about y?
Minus of 0.246.
0.0246. Is it correct? Okay. So you see, we are getting a very close solution now, which is exactly 1.2. So in just four step, we are in a position to guess the solution, right? Okay. So at this point, if you wish, you can stop. Otherwise, you can continue. And I am sure after a couple of cycle, you will get something like 1.2 as a correct solution. Okay. I hope this method is clear to everybody. Are there any queries? Yes, students, are there any queries? Okay, both. Yes, any queries, please? Okay.
No, sir.
Okay, fine, fine. So both methods they work on the same process. Only thing is the equation is different. This equation is slightly advanced, and the bisection method is a very crude and very basic method. Okay. So now let us try to solve another problem, and I want all of you to solve this. So in the previous class we have solved this. This is a third order equation. So this is y uh, equals to x to the power 3 minus 1.5 times x square. Okay, so let me write down that expression over here. So this is second example. So this is y equals to x to the power 3 minus 1.5 times x square. And if you see in the previous class we have seen this is 1.5 is the correct solution. Okay, so let us try once again with this. And I'm just going for the table. Okay, so this is 1 2 3 4 5 6. This should be sufficient. So this is x1, this is y1, this is x2, this is say y2, this is xm, and this is ym. And last time we have chosen something like 1 and 3 as a guess roots. Okay, so this is 1 and this is 3, and the corresponding y1 and y2 was minus zero point 0.5, and this is 13.5. Okay, so this is minus 0.5 and this is 13.5. Okay, so in the bisection method we are lucky because the exact solution was I think it is 2, right? So in just 2 cycle we are able to get the solution, but that was a simple pure luck. But ideally it should take more iterations. So let us try to solve the same problem using this regular falsi method. So can anybody tell me what will be the value of xm? So for xm you have to use an expression something like this. So this is x1 y2 minus x2 y1 divided by y2 minus y1. Okay, the same expression which we have seen earlier. Okay, so please tell me what will be the value of xm now.
1.0714.
14. Okay,
Still 071.
1.07. Okay, what about y? Please someone verify this, is it same or not?
Same, sir.
Okay, give me
Yes.
the value of ym then.
Minus 0.4919.
Minus 0.4913.
19.
19. Okay, okay, okay. So we got now two values. Okay, so now we have to keep on iterating unless and until we get the correct solution. Okay, so since this value is negative and this value is also negative, I'll keep the positive value as it is. This is plus 13.5. Okay, let me put a sign also over here. This was plus, so I'm going to change this value to 1.0714 such that the corresponding y value is minus 0.4919. Okay, so can you tell me the value of xm and ym please?
1.139.
1.1392. Okay, how about this one? इसमें बेटा ज़्यादा iterations आएंगे because in the bisection method we got lucky.
Minus 0.468.
Minus 0.
68.
आगे
2, sir.
ठीक है. Okay, So you see the value of y is slowly reducing. It is initially 0.49, then it becomes 0.46. The rate is not that good, but if you take couple of cycles, I'm sure you will be reaching to the exact solution. Okay, I hope you have understood this. किसी को कुछ डाउट है बेटा इसमें? Go for one more cycle, please. Go for one more cycle. So we have to keep the positive value as it is. Okay, so this is plus 13.5. Okay, negative value I am going to change 1.1392, and this will be minus 0.4682. Go for the one more trial, please.
1.2013.
Okay,
The YM is minus 0.430.
okay, 4308. Okay, so like this you just have to keep on going again and again, and we have to stop when either the y value is becoming 0 or the xm values. Okay, so two consecutive values of xm, they should be in the similar range. Okay, so here you can see in the previous one it was 1.1, then it is 1.16, 1.18, 1.19. So if I am getting 1.19 one more time, I can stop. Okay, so if I am having a, if I want to have a accuracy correct up to, let us say, 2 digits, so if I am getting two values of 1.19 consecutive values as 1.19, then definitely I can stop. Okay, so this is how this method is going to work. So I am sure both the methods are clear to everybody. Are there any questions? Are there any queries? No? Okay, good. So now I am going to give you one problem, and I want all of you to solve the same problem by both the methods. Okay, one with the bisection method. So here I am writing, okay, and the second one is with the Regula Falsi method. Okay, so the problem is like this. Let me note down. So till now we are using a simple equation. Now we will have some complex equation. So the equation is like this. So this is y equals to, y is basically a function of x, but this time I am using x into e raised to power x, okay, minus 3. Okay, so now I want all of you to solve this problem, and just to start with, I'll tell you a hint that the value of y is negative, okay, when x is 1, and value of y is positive when x is 2. This means what? The actual root lies in between 1 and 2. So I want all of you to prepare two tables, okay, and first you try to find out the solution with bisection method, and then you try to find out solution with the Regula Falsi method. And I suggest you go for bisection method up to just up to 5, you can say 5 number of iterations, and see what are the values of xm you are getting. Okay, so please start working on this. I'm giving you sufficient time, and just give me the values of xm only. Okay, give me the value of xm. Just 5 iterations. Okay, give me the value of xm of bisection as well as regular false method. बाइसेक्शन में पहला वाला तो आई थिंक 1.5 ही आएगा. Okay, and what is its corresponding y value?
3.7225.
3.7225. Okay, good. The next one.
That is Regula Falsi 1.023.
तुम पहले रेगुलर फॉल्सी कर रहे हो क्या? ओके.
हाँ सर, कल क्लास में सर
अच्छा, एक सेकंड, मुझे चेक करने दो कितना आ रहा है.
1.023.
23 आगे.
सर आगे का लिखिए.
3 आता है. हाँ, y वैल्यू कितना है इसका?
-0.1536.
6 आ रहा है. ओके. ओके, प्लीज simultaneously you can work and give me the values. Why I am writing both the values simultaneously, so that you can understand which is faster. Okay, one iteration, second iteration, third iteration, and after 5 iterations, see where you are going with which method. Okay.
For bisection,
Hmm.
1.25.
Okay.
And its corresponding value is 1.362.
1.29.
362.
Okay.
Sir, by Regula Falsi,
Hmm.
1.55.
1.55. How about its y value?
-0.0834.
3, 4. Okay, good.
Sir, for bisection, 1.125
Okay.
and 0.4652.
आगे. 52. Okay, good.
Sir, for bisection,
Hmm.
1.062. 0.07.
Positive.
Sir, for Regula Falsi,
Hmm.
third iteration, that is 1.0422.
Hmm.
Y is minus 2 point. थर्ड वाला इक्वेशन बताया था सर.
Yes. What will be the y value?
0 point minus 0.448.
कौन सा वाला बता रहे हो?
हाँ सर, थर्ड इटरेशन का.
रेगुलर फॉल्सी का
हाँ,
0.448.
0448.
Okay, fine.
bisection
Hmm.
1.039.
Okay.
125, sorry.
125. Okay.
Minus of one minus of point 107.
Minus 0.1078, right? Okay. Oh, please complete these two XM.
For Regula Falsi, XM is 1.045.
45. 8. Okay. Corresponding Y value.
Minus
Hmm.
0.0239.
Okay. ठीक है. Can we have one more for regular Falsi? Yes. Last one, please.
Sir, XM is 1.0477.
Okay.
And sir, YM is minus 0.0129.
129. Okay. Good. So now you see, uh, if you see the pattern, right? Especially if you see the pattern of regular Falsi, you'll find the values of y all are negative. Okay. So since all are negative, and if you see the pattern, the value of y is slowly approaching towards the zero. So initially it is 0.1, then it became 0.08, then 0.04, then 0.02, and 0.01. Okay. I'm sure if you go for a couple of more cycles, you are going to get value which is even closer to zero. Okay. And if you see the bisection method, initially for 4 iteration it was positive, and in the fifth iteration suddenly it became negative, because here you see in the bisection method the y value jumps between positive and negative. Okay, sometimes it becomes positive, sometimes it becomes negative. But if you see the absolute value of y, so initially it was 3.7, then it was 1.3, then it becomes 0.4, then it becomes 0.07. But once the sign is changed, the suddenly the value of y has increased to 0.1. Okay. So if you talk about just 4 iterations, forget about the fifth iteration, just if you talk about the fourth iterations only, in 4 iterations you are getting more accurate result in regular Falsi method, because if you see the value of y in the regular Falsi method, it is 0.02, whereas after the fourth iteration the value of y in the bisection method it is 0.07. Okay. So all we have to do is the follow the same process, but if you use the regular Falsi equation to calculate the value of xm, so it is giving you much better performance as far as the bisection method is concerned. Okay. So after the fifth cycle, if you continue with the bisection method again, you may end up with some positive value or even a negative value. So basically the window is narrowing over here. And in case of regular Falsi method, if you increase the number of iterations, it will be even reducing. The value of y will be continuously reducing. Okay. But as far as the actual solution is concerned, for this particular problem, I have the actual solution. The actual solution is, um, let me check. Huh? Actual solution is something like 1.04, something like that. Okay, let me check one more time. I think, yeah, it is 1.0488. Okay, so let me write down. So this is the actual solution is 1.0488. This is the actual solution. But if you see this, we are very close over here, and as far as this part is concerned, or even if you see this value also, this is no way closer to the actual solution. So if you compare the regular falsi method, one thing is sure, that the regular falsi method is fast, but uh, there is another or the same drawback which regular falsi method has. Even the bisection method is also having, that we have to choose two routes. Okay, we have to choose two routes such that one route should be on the positive side and second route should be on the negative side. So if you see the notes of your bisection method, when we have started with the bisection method, we have chosen this equation, that is y equals to x to the power 2 minus 2x plus 4. We have tried many guess roots. We have started with minus 1, 0, 1, 2, 3, and so on. Every time we are getting a positive value. We are not in a position to get one root which is negative. Okay, तो इसमें क्या होता है, ट्रायल एंड एरर बहुत ज़्यादा होता है. We must have at least one point which is on the positive side and another point is on the negative side. If we don't have those 2 points, we cannot solve the problem either bisection method or a regular falsi method. तो दो पॉइंट बहुत जरूरी है, isn't it? So this kind of limitation is there with both the methods, that we need to have 2 points. But when we will see in the next class, in the next class we will study the Newton-Raphson method. Now in the Newton-Raphson method, this drawback is completely removed. So in the Newton-Raphson method, we don't need 2 points. One point is sufficient enough for us. With that one point, that point can be anywhere on the curve. Okay, anywhere on the curve, you will get the correct solution. So you don't have to go for trial and error. Ki one point is on the negative side, one point is on the positive side. That part is completely removed in the Newton-Raphson method. Okay, so this method we will be covering in the coming classes. Okay. I hope today's method is okay with everybody. Are there any queries?
No, sir.
Okay, then. We will stop now. So I want all of you to leave. If you have